All right, welcome back everybody to your second class this week. Last day we looked at basically what alkanes were, and we looked at this page. So if you weren't here last day, these lectures will be uploaded eventually to YouTube. But I mentioned last day that you guys needed to know, excuse me, the first 10 members of what's called the homologous series, or basically the first 10 chains of alkanes. So it starts with 1 carbon being methane, 2 being ethane, and then it goes up from there. So I did this yesterday, or well, not yesterday, but in our last class. So make sure you know that or know this. Then I very, very quickly went over the many different types of formulas in organic chemistry. So let me just kind of review that for you guys today. There's the general formula. So this is the formula you probably would have seen in chemistry 1120. So like this example, this is 1-propanol. This would be C3H7OH. Doesn't really tell us much about the shape of the molecule. It's good if you need the molar mass, if you're doing a question like on stoichiometry. And don't worry, there's not much stoichiometry in this course, but it doesn't really tell us the shape of the molecule. And knowing the shape of the molecule, like for example, the Lewis dot diagram, it can tell us a lot of information about that molecule, the boiling points, if it's soluble in water. So it's really important to know the shape of molecules in organic chemistry. So there's another formula. This is not a formula we will be using, so you don't really need to know this formula. There's a way to represent this that kind of shows the shape of the molecule. It's called a condensed formula. But typically in organic chemistry, we use 2 types of molecules. We would use the structural formula or the skeletal formula. And honestly, the easiest and best one to know is the skeletal. So let me just go back and explain what the structural is. This is something you guys did in chemistry 1120. And then the skeletal is kind of new for you guys. So I got a couple things in the chat going on. Mohammed says my sound isn't clear. That might be my internet at home. Hopefully it clears up soon. And Maria asks if there can be a compound called methene or methylene. So no, not really. Let me just see something. Methylene. I feel like I've heard the word methylene before. Okay, so to answer your question, Maria, methene is not really something I've ever heard about before, or methine. I haven't heard about methine either. So methene or methine, no. Because in something like, and there's another question there I'll answer in a minute, but like in order for something to be called ene or ine, it needs to have double or triple bonds. So this would be ethene, and this would be ine. Sorry about my writing there, not very clear, is it? But with methane, because there's only 1 carbon, you can't really do that. But the minute you wrote in the chat, you said methine, and I thought you said methylene. There is a compound called methylene. It's a little more complicated than we need to get into in this course. It has something that we call free radicals. Definitely not something you need to know in this course. So to answer your question, methene or methine don't exist because they can't have double or triple bonds. Okay. That's a really, really good question, something we could get into more detail in another course. But for Chemistry 1120, you don't need to worry about it. And Aman asked a question, so general and condensed formulas, you don't need to know or study them. No, not for chapter 1. Once we get into chapter 2 and chapter 3 and chapter 4, we're kind of going to go back to Chemistry 1120, and we will be using general formulas. Chapter 1 is very different. It's about organic chemistry. And in organic chemistry, we tend to use structural, or more importantly, what I'm going to be using, excuse me, is skeletal. So Aman's question about general, condensed, no, you never need to know. So condensed, not something I really care about. General, we'll kind of come back to general in chapters 2, 3, 4, and 5, because chapters 2, 3, 4, and 5 are more traditional chemistry, what you're kind of used to from Chemistry 1120. Okay, some really good questions from you guys. I have a feeling we're going to have a really fun semester because I love all of your questions. So structural formula, I won't spend a whole lot of time on this. This is what you would have called in 1120 the Lewis dot diagram or Lewis structure. This tells us the shape of the molecule. But the problem with the structural formula is it includes so much extra information that we don't need. It includes all of the hydrogens. And if you're an organic chemist and you're, talking about complex organic structures, you don't want to worry about hydrogens. They're not important. They just take extra time to draw. So the way that we typically represent formulas in organic chemistry is with what's called the skeletal formula. We use lines, and we'll kind of review this as we go through this chapter, but we use lines to represent the carbon chains, and we ignore any hydrogens on the carbons. So some of you might be thinking, well, hold up, wait a minute, you're putting a hydrogen right there. What's going on? Well, the reason that hydrogen is included is because this is what's called a functional group, which I think I'm going to get into today if the time permits or allows. So for functional groups, hydrogens bonded to things like oxygen, sulfur, or nitrogen, we would include them. But for all other hydrogens, we ignore them. And the idea is, and this is going to sound like a complicated definition, but it's really quite easy once I kind of get into this and show you how to do it. The way that this works is carbon atoms are depicted or represented as the end of the lines. So in math, you would call them vertices. And you assume that all carbons have a valence of 4. And, if I'm leaving anything out on these carbons, it's full of extra hydrogens. So this is like the skeleton of the compound. And if that's still confusing to you, we're going to do a lot more of this in this chapter, so don't worry. So this is kind of summary of what I just said. There's 4 ways we can represent a chemical formula. There's the general, which we will come back to. General is the only good thing about general is it's easy to calculate molar mass. And as you guys know from Chemistry 1120, the molar mass is really good for us when we're doing stoichiometry. There's the condensed formula, which we honestly, I haven't seen very much, in textbooks, in academic journals, in other courses, you don't see condensed very much. There's structural, which is a really good way to represent the shape of a molecule, but it's time consuming. There's a lot of writing. And then there's skeletal. Now, keep in mind, guys, these are all the same chemical. This is all, it's called 1-propanol. So just have a look at the skeletal. It's 3 carbons in a row, right? So 1, 2, 3 bonded to an OH. So the way that this works, let me pick a different color here. I'm feeling green today. So we have 1, 2, 3, and then our functional group, 1, 2, 3, and then the functional group. So skeletal, every time the chain, it's called a chain, every time the line bends, there's a carbon there. So that's 3 carbons with a alcohol functional group. And I think, yeah, this is exciting. This will probably be the last thing I'll do today, is I'm going to explain to you all the different functional groups, and then we'll do a little practice, and then that's it. All right, cool. Any questions so far? How are you guys doing?
Doing good, sir. It's okay.
All right, perfect. Sorry, I'm just checking the chat there. Iman, that's a really interesting point. It's hard, like, the question is, I was referring back a few minutes ago about the OH group. And Aman said, oh, well, it's not hydrogen, it's hydroxide. And that's kind of true, but you're kind of thinking about 1120, where we have an ionic, oops, sorry, I didn't mean to do that. When you have an ionic compound, so something like sodium, which is a metal, bonded to a polyatomic ion, this is, of course, what we would call the hydroxide ion. But when you're dealing with organic chemicals, one important thing to remember is that none of these are ionic. There are no ions. So we can't really call this the hydroxide ion. So again, when I draw something like this right here, because it's not ionic, we can't call it hydroxide. That specifically refers to an ion that has a charge. Charges happen when electrons are transferred from one chemical to another. Covalent compounds, like organic compounds, there's no transfer of electrons. They're all shared. So important distinction there. Okay, so just give me 1 second and I'll start explaining functional groups, and then we'll be done for today.
Mister, we cannot hear you.
Yeah, sorry. Okay, so in organic, let me just see if I can clear my screen really quickly. Here we go. In organic chemistry, functional groups are specific groups of atoms, so like OH, like we just saw, or bonds within a molecule that are responsible for the characteristic chemical reactions of those molecules. So the reason that functional groups are so important, and let me change my color here. I think I'm going to go back to red. The reason that functional groups are so important is because they kind of control or define how a chemical reaction can happen with that molecule. And what I mean is, something like an alcohol will react very different than an alkene, or something like a carboxylic acid, which you'll see today, will react very different than a ketone. So the same functional group will undergo the same or similar chemical reactions, regardless of the molecule it's part of. The important thing to consider here is that the reactivity of that molecule can be changed by nearby functional groups. So in simple words, functional groups are responsible for chemical reactions of molecules. They really define how the chemical and physical properties of that molecule are in nature. So what you guys need to do is you need to memorize all of these. I'm obviously just kidding. You don't need to memorize all of these.
Oh my God, sir.
I'm joking. I'm joking. Don't worry. You do not need
Okay.
to, you do not need to memorize all of these. You only need to know a few of them, and I'll kind of highlight which ones. I mean, of course, you should know an alkane, an alkene, and an alkyne. So single bond, double bond, triple bond. But this is an amazing infographic, is what they call this, but you really only need to know a few of them. So we'll be looking at today. Let me pick a different color here. Let's go purple. Alcohols, aldehydes, ketones, carboxylic acids you should know. Ester, I'm kind of reading through the list now. Ester and ether, amine and amide, and I think that's it. Let me look through the rest of the list. Yep, that's it. So where you see the purple check marks, these are ones that you should know. And this might seem complicated, but it's actually pretty easy. It is a bit of memorization. But these are like the important functional groups, the classic functional groups that you'll see. It can get a little confusing with amine and amide, for example, because, I mean, in English, there's only a difference of one letter, the N and the D, but it's pretty straightforward. So let's have a look at these. We'll do some practice problems. That's it. Halas, we're done for today. So let's start with, I think we're going to start with alcohols. Yeah. In organic chemistry, an alcohol is an organic compound which has the hydroxyl group. Now, you don't need to memorize that. I know Iman mentioned a few minutes ago, she called it hydroxide. That's if it was an ion. These are not ions, they're parts of covalent molecules. So we call it hydroxyl. You don't need to know that for this course, don't worry. What you do need to know is that alcohols are a carbon chain with an OH bonded to them. Now, one important thing I should mention, before we go any further. What does this R mean? R is a carbon chain. Like in math, if you don't know a number, you would call it X, right? So in chemistry, R just represents any carbon chain. It could be, like this is propanol, or one propanol. It could look like this. R just means the carbon chain. So when you see ROH, what I mean is it's any carbon chain, R. It could be anything. I mean, it could be like it could be the craziest carbon chain you've ever seen. Like it could be choo. We could put a ring in here, right? You could do anything. But R just represents that carbon chain. Again, it could be as simple as ethane or methane, or it could be as complicated as whatever this guy is. So R is just a carbon chain. So alcohols are a carbon chain that has OH attached to it. You can see the names down here. You guys aren't really responsible for naming these things. If you go to the next chemistry course, Chemistry 3, Chemistry 2420, we'll learn how to name these things. But for today, you don't need to worry about that. All you need to know is that if you have a carbon chain and it has an OH attached to it, it's what we would call an alcohol. All right, next functional group, ketones. And let me just check the chat there. I think I got a message from somebody. Oops. So I've been using Zoom for a long time, for weeks. No, not even weeks, for months, and it's still so hard to get the chat screen open. I heard I can sync it to my phone, but I've never done that. Okay, hold on one second. My computer is being really mean to me. There we go. Yeah, so as Maria's just said in the chat, R can be an alkane, an alkene, an alkyne. R can even be a benzene ring. R can be anything. Okay, so ketones. Ketones is an organic compound where you have a double bonded O in that molecule. Now, this is where it gets a little confusing. I don't know why. And like, as long as I've been teaching chemistry, 11, 12 years, something like that, I've always wanted to know this. For some reason, chemist people decided to make a difference between a double bonded O inside a molecule and a double bonded O on the end of a molecule, which I'll show you now. And I'll explain the difference between these two, don't worry. An aldehyde is just like a ketone, and I apologize for this. I don't know why they did this in chemistry. But an aldehyde, which I would assume comes from some Arabic word, is a ketone or a double bonded O, but it's at the end of a carbon chain. So, okay, what the heck, right? What's going on? What's the difference? First of all, I don't know why they did this. I think it was just to confuse students and people like me, but let me just give you like some examples. So, okay, let's go over here. I'll just draw a few ketones. So ketone, you can have a carbon chain as long as the double bond is inside the chain. So I could draw something huge, right, with lots of branches and all sorts of crazy stuff. As long as the double bond and the oxygen, of course, is inside the chain, it's a ketone. So aldehydes. What's an aldehyde? Well, an aldehyde is when the double bond, whoops, sorry, my pen there, is on the end of the chain. So again, I can draw crazy chains here. I can do whatever I want, but as long as the double bond is at the end, it can be at the beginning too, right? So the difference between a ketone and an aldehyde is that ketones, the double bond is inside the chain. It's not on the first or last carbon. And an aldehyde is always at the end. I don't really have any other things to say about that. Like, I don't have any tricks or any ways you guys can memorize that. But it's just confusing, and I don't know why they did it. These pictures, by the way, I got from a book, of course. So they're, a little different than how I would draw them. Like, for example, propanone. You could just draw it like that, right? So we have 1, 2, 3 carbons, 1, 2, 3. But it's hard to find images of these things unless you make them yourself. So I used a book. And it's a little different than skeletal, but still it shows, most importantly, it shows that the double bond in the middle is a ketone. Double bonds at the end or the last carbon are aldehydes. Okay, couple more. Carboxylic acid, ether, ester, amines, amides. So there's 4 more, and then we'll do some practice, and then halas, we're finished. Okay, carboxylic acid, one of my favorites, actually. If you guys, maybe you like fish and chips, or I know that's like a British thing, but if you guys like vinegar, so maybe you like salads and you like vinaigrettes, vinegar is a carboxylic acid. It's called acetic acid. These are organic compounds that are like a combination of alcohols and aldehydes. So a carboxylic acid is a compound that contains what we call a carboxyl group. And as you can see in these pictures, it's basically like an aldehyde. There's a double bonded O and an alcohol. These tend to be quite acidic, and the reason they're acidic is because of this hydrogen right here. If you remember from 1120, and even if you don't, we're going to talk about this more in this course. I have a whole unit for you guys. Unit 4 is all about acids. Acids are defined by how they donate hydrogens or give away hydrogens. So yeah, you don't need to know that right now, don't worry, but you should know that a carboxylic acid is it's at the end of a chain, and it's when you have a aldehyde and an alcohol stuck together. This is one functional group. There's a question that I typically ask my chemistry 2420 students. I give them a big molecule and I say, you know, how many functional groups are on this? And a common mistake that they make is they call this 2 functional groups. They would say, oh, it's an aldehyde and it's a ketone, or sorry, an aldehyde and an alcohol. But no, when they're together like this, it's just one functional group. So some fun facts before I move on to the next slide, if you're wondering. If any of you guys go to the gym, or you work out, or you hike, or you bicycle, or whatever, do you ever notice after you work out, maybe you go to the gym, you ride your bicycle for a while, your muscles get sore? This is because of lactic acid. Again, I am not a biologist, so don't ask me too much about this, but I am a chemist, and I do know that when you have sore muscles, typically from working out, it's because of a buildup of lactic acid in your muscles. So, you know, when you work out, you're basically damaging your muscles, and then they heal, and they become, you know, bigger as they heal and heal and heal. They become stronger, which in itself is amazing. But the reason that, like, you know, after a long hike or a bicycle ride, or even like for me, like carrying luggage through an airport, sometimes my arm will hurt. It's because the lactic acid in your muscles is burning you. Totally normal, totally healthy. But just, yeah, a fun fact. I have another fun fact. Formic acid. So one of my favorite, and this, you guys might find this weird. Please don't think I'm weird, but one of my favorite creatures. I love bugs. I love like spiders. I love ants and everything. I'm not a fan of cockroaches, but ants have a chemical inside them called formalin. And when you squish them, so if you had a bunch of ants and you stepped on them, they would release formic acid. So sometimes, I don't think this happens in Qatar very much, but there are ants around the world, like fire ants. We have them where I'm from. If they bite you, it burns like, you know, like a fly bite, but times 10. Like it's almost like a bee or a wasp stung you. And this is because of the formic acid in those ants. So another fun fact is ants are made of formic acid, or not made of, but they have formic acid. And I think the name formic comes from the Latin name for ants or something like that. I don't know, but I do like ants. I think they're super cool. I don't have a fun fact about benzoic acid, I'm sorry. All right, so let's move on. A couple more and then we're done. Ethers. Okay, ethers. Now these, you might see these in movies a lot. ethers can be anesthetic type compounds. So have you guys ever seen, like in a movie, some, and this is a kind of a dark thing to mention, but in a movie, they take like a cloth full of a liquid and they put it over some guy's face and they pass out. Typically, that would be something like an ether. Ethers are good solvents in chemistry, meaning they help dissolve things, but they're also good anesthetics or painkillers. So in heavy doses, they can knock you out. Ethers are oxygens inside the carbon chain. So you'll notice that, like, this isn't a double bond. This isn't bonded to a single carbon. This is actually inside a carbon chain. I'll kind of show you the difference between all of these at the end of class. I'm almost done today, by the way, guys. I'm sorry I kind of rambled a little bit about some fun facts, but anyways, we're almost done. So ethers are inside carbon chains. Esters are just like ethers, but they would be combined with a ketone. So they would have a double bond to the oxygen and a single bond to the oxygen inside the carbon chain. Again, I'll explain, or I'll show you a summary of all of these in a minute. So esters, I don't have really any fun facts about esters, but I do know, and you guys will see this in your labs, esters typically have a good smell, or an interesting smell. They can smell like mint or pineapple. You'll see this in your lab. You guys probably had your safety labs this week. I'm not your lab instructor, as you know, but you'll start your labs like lab number 1 next week. Check your lab schedule. Make sure you're reading your lab schedule, but you'll see this in your lab 1. Okay. Again, check with your lab instructor. It might be Michelle, I think your lab instructor might be, but you'll look at this in lab number 1. Okay, there's 2 more. I'll do these really quick, and then I don't know if I'll have time to do these practice problems. Maybe we can do these tomorrow. So there's 2 more. Then I'm going to give you a summary, and I think what I'll do is save these practice problems for tomorrow. Okay, so little different now. We're going to leave oxygen away, and we're going to talk about nitrogen. There's also an interesting functional group formed from sulfur, but we're not going to get into sulfur in this course. So the functional groups we learn are nitrogen and oxygen. So amines, what the heck is an amine? An amine is when you have a nitrogen bonded to a carbon chain, full stop. It doesn't need to have a hydrogen. It's as long as there's a nitrogen bonded to a carbon chain. It could be NH2, it could be NH1, it could be N. Again, it doesn't matter. It's when there's a nitrogen atom stuck to a carbon chain. These compounds tend to be bases. So unlike alcohols or carboxylic acids, which are weak acids typically, these are weak bases. Sorry, just checking the chat here. Ooh, good question. So Maria asked if amine is related to amino acids. Kind of. Okay, again, I'm not a biologist, but amino acids, these are the building blocks of human life. I mean, if any of you guys are in biology, you've definitely learned about amino acids. Amino acids make proteins, proteins make life. Amino acids would typically have a nitrogen in them. So yes, amines are definitely related to amino acids. I'm not sure where the term amino comes from, but if you look at amino acids, So like arginine or lysine or threonine, asparagine, or I don't know if I'm saying these right, but if you look at any amino acids, they will always have an NH group in there. So amino acids, every one that I've looked at have an NH2 group, like literally every single one. And you know what's interesting about amino acids is I'm looking at a picture on my computer now of like a lot of them. They also are carboxylic acids. So if you think about that, an amino acid was probably named that way because they have an amine and a carboxylic acid. I think I just learned something, and I think you guys might have learned something. I would be fairly confident that that's where the name comes from. Amino acids contain an amine group and a carboxyl, or what we would call a carboxylic acid group. Yeah, cool. That's interesting. Very interesting. I never knew that. I wish I knew that when I was doing biology 20 years ago. Anyways, so the last functional group, and guys, I'm almost done, I promise. What I'm going to do, I'll explain amides. I'll give you a summary of all of them, and then Halas will kind of do some of these practice problems tomorrow. Amides are very much like amines, except of course they have an aldehyde or a double bonded O attached to them. Again, I don't have any really fun facts about amides. They're used in nature and technology as structural materials, so they help like form the structure of things, but I don't have any fun facts besides that. But an amide is a double bonded O next to an amine. Okay, so finale. See if I can get you guys out of here by 4:20. Let's do, first we'll do alcohols. So an alcohol is a chemical compound with an OH. A ketone, it's a chemical compound very much like the alcohol, but instead of an OH, it's just a double bonded O. An aldehyde, and again, I do apologize in the history of science that I don't know why they did this to you, but an aldehyde is identical to a ketone. It's just that it's at the end of the carbon chain. Again, I do not know why. Carboxylic acid. All right, so this is like, oops, sorry, this is like vinegar. Carboxylic acid is a carbon chain that does have an, let me draw that a little differently, does have an alcohol, but it also has an aldehyde. So it has a double bonded O and a OH. What was my, ether. So an ether is a lot different than these chemicals. The ether has the oxygen in the chain, so it's in the middle. Did I have a question there? Someone have a question?
No, sorry, sir.
Okay, no problem. An ester is, how am I going to draw this? I'll draw it like this. Is a ketone with an ether group next to it. All right, what are my other ones? I think I only have two left. I have amine. So this is a carbon chain with an NH attached to it. Again, an amine can be, it doesn't have to be NH2. It just has an N. Like again, N, don't worry about anything else. As long as there's an N, it's an amine. And then finally, amide. This is an amine. Let me draw that differently. I'll draw it kind of like the carboxylic acid attached to a double bonded O. So there you go. There's your summary in purple of all of the functional groups you need to know. And again, you guys, I know this isn't the most interesting thing, but for any of you guys going on to chemistry 2420, you have to know this. And this is actually, I think it will do this in 2420 in chapter 2. So very, very, very important that you know this for 2420. Not as important in this course. This would be maybe like a multiple choice question or something like that. But definitely something you guys need to know. I'm going to stop there because it's 4:22. I went a little longer than I wanted. Tomorrow, you guys might want to take a screenshot or a picture of this, by the way, because it's not in your notes. But tomorrow, we'll do some practice problems. So I'm going to show you some complex molecules, and we'll identify the functional groups on those, which is a wink, 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 a very good test question. Wink, wink, wink. Okay. All right, everybody. Thanks very much. Before I sign out, do you have any questions?
Thank you, Mr. Mark.
Thank you.
No, sir.
Thanks,
Thank you
guys.
so much.
Thank you. Have a great day. I hope you enjoy your evening, and I'll see you soon.
Have a great evening too, sir. Goodbye.
Bye. Thanks. Have a great evening. See you later. And as Maria said, yeah, we don't have class tomorrow, but we do have class on Thursday at 11:30. So I'll see you then. All right. Goodbye, guys. See you Thursday.